Hi, I'm Doc Palmer. I'm the author of McGraw-Hill's best-selling reliability book, the Maintenance Planning and Scheduling Handbook. Maintenance planning and scheduling is a best practice, but it's also one of the most frustrating practices. People want to make perfect job plans, and people want to make perfect schedules and achieve the schedule. Those lead to frustration. Instead, we want to run planning as a Deming cycle where we give head starts and then entrust professional craftsmen to exercise their judgment, update the job plan with notes so we can do a better job in the future. We're running that Deming cycle. On the scheduling, most people think the purpose of scheduling is to complete the schedule, so they underload the schedule and have good schedule compliance. But they fail to achieve the real purpose of scheduling, which is to help us complete more work than we would normally complete. To do that, our enemy is Parkinson's law, which is the amount of work assigned expands to fill the amount of time available. So we need to fully load schedules and expect lower schedule compliance because there is churn and breakdowns in real life maintenance. And then we will achieve a pop in work order completion rate, which is our real objective for scheduling. Today, we want to continue our talk about the Computerized Maintenance Management System. It's now called the EAM, Equipment Asset, or Electronic Asset Management, but maintenance, it goes beyond just maintenance. But we'll just call it the CMMS for now. I want to just quickly go through the benefits and some of the cautions that you can be aware of. First of all, having a CMS really helps us standardize our work processes. People have to fill in certain fields to give you certain information. They can't leave an area of the work request or notification blank. And we have drop-down lists where they can pick from certain values, so everybody describes something the same way. Now, people can still pick the wrong values and stuff. And there might not be a value that exactly meets their thoughts. But it gets us closer to collecting information. And then that electronic work order from the requester goes to the right authorities for approval and goes to the planning. So everything, that process is more carefully protected. It's not just a piece of paper didn't end up in the right place and you don't get the information you want. And then inventory control. It's a huge bang for the buck. Automatic reorder points. So we don't buy too much, we don't buy too little. We're supporting that reliability of the plant, which is where our real money is. There's a lot of money to waste in the storeroom too, though. We want to have control over those reorder points and things and know what's in the inventory. Information, just information in general. What's your most troublesome piece of equipment? Well, how would you know with a paper system? Is it your fattest file with the most work orders in it? But with a computer, you can look for that most troublesome equipment, your bad actors, where are we spending the most money. And then information as far as, are we doing more and more preventive maintenance every year or less and less preventive maintenance every year? How would you know that without a computer? Are most of our work orders that are being generated coming from preventive maintenance inspections, predictive maintenance inspections, or are they people just finding stuff? Or are they people that just have emergencies that come up? And how do you sort all that and get a feel for if you're controlled or not? The computer and electronic system helps us deal with that. And then just finding work orders. You can lose an electronic work order, but it's a lot easier to lose a paper work order. And then linking information together for the equipment in a common database. You don't want the electricians having a separate database on motor frame sizes. The predictive maintenance people seem to have the best nameplate information. The planners have the work order history. Now we need that all together in the same system where everybody can have the latest information and access. Schedule manipulation should be a benefit. The IT group that's involved with the creation of the electronic scheduling systems, they tend to make those a little overkill because the IT person, and I'm not using that in a derogatory term but I'm just separating the IT person from the maintenance person. The IT person really thinks a job estimated for 5 hours, it should take 5 hours. And so they want to make daily schedules a week ahead of time. Well, in real life, we have slow mechanics and fast mechanics. On corrective maintenance work orders, we don't know the exact scope of the job sometimes. We think we need to replace the impeller. Do we need to also replace the bearings? Is there a worn spot on the casing when you open up the pump? And jobs just take longer or shorter than you estimate sometimes. There's a wide variance from the estimate, even though there's a fairly normal distribution. So we can use those estimates to generally build schedules and generally assign work, but making daily schedules a week ahead of time just leads to having to revise the schedule every day for the rest of the week. Why not just start off with a week's worth of work and then assign the days as we go through the week? That would be my preference. Now, I suspect artificial intelligence will help us with that, but we don't want to take away supervisor responsibility to manage the churn in the week, and we do need supervisors out in the field to do that. PM generation is wonderful with an electronic system. That monthly PM is going to come out every month with the right information to the right people. We don't have to worry about forgetting to copy it and send it to the right people. It'll show up when we need to see it. And then just general problem diagnosis and root cause analysis. Have we had that problem before? What did we do about it? And the larger your company is, spread out over the globe, somebody in your company has had that problem before with that model pump. And what did they do about it? That's a wonderful heads up for making a maintenance plan and a maintenance strategy to deal with that. And then, what is your biggest problem at your plant? Is it cathodic protection at the fuel oil tanks out at Northside Generating Station during the spring, out at the waterfront? But it's actually not a cathodic protection problem. It's an electrical problem associated with the cathodic protection problem. Cathodic protection. And then you can spend money and work orders to deal with that. And that's a lot more difficult to do with a paper system. So some important cautions, computer cautions. If you don't know how to do maintenance without a computer will not help you do that. If you do not know how to add, multiply, subtract, and divide, you have no business with a handheld calculator. So if you don't know that maintenance is about keeping things from breaking, and so we want to have work in our backlog to do on equipment that hasn't broken yet to keep it from breaking, and know how to do that without breaking it, but you think instead that maintenance is fixing things really quick when they break, the computer will help you with both of those things. But you don't understand maintenance, and you're not into the big money, which is keeping things breaking to begin with. And by the way, a very reactive plant is a much less safe plant. It's a more environmentally faulty plant. It's a more legally liable plant. That's what a reactive plant is. But you can do maintenance that way, fixing things as soon as they break. But that's not what modern maintenance is about. Modern maintenance is about keeping things from breaking. So we need to do a better job with predictive maintenance, preventive maintenance, reliability-centered maintenance to develop our strategy, PM optimization, and all those different things, instead of just using the CMMS as a work order database. And then the computer is just a big distraction. I go to a lot of places and it seems like they're saying, as soon as the CMMS is fully implemented, everything will be fine. Well, that's just not true. That's two lies. It will never be fully implemented. And even if it was, that doesn't mean you know what you're doing with maintenance. So it's an incredible distraction that you're trying to, your big program for the year is to implement this huge computer system. And you might not know what maintenance is. So that would be a great distraction for you. And then these systems don't come out of the box ready to use forever. They're always having upgrades. Big upgrade every few years, a little patch every few months where you implement it. And if you've made any customizations instead of just configurations. You're going to have to remember to do those right. If you're linking two systems together, you CMMS with a enterprise asset management. That's what the EAM stood for. With a company financial systems, are your links going to break when this system puts in a patch? Is it still going to talk to this system? So cautions, be careful with that. And then the system reliability and speed. When we first had the diskettes that we plug into the computer, the system ran pretty fast. When we went to client server, it was click, 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 hyperlink, hyperlink, back, click, click, click. System went pretty fast. Then we went to web enabled. Everything just slowed down. Wah, click, wah, electronic spinning donut. We've got better computers now with a lot more gigabytes and RAM and stuff, and so the speed's back up. It's back to click, 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 click. Data protection. Is a server going to crash and you're going to lose all your work orders for the last year or the last couple of days? Most of these systems now run on multiple servers, so if a server crashes, you won't have a data protection problem. Improper costing. Would you believe that people assign parts and time to the wrong work order number? That still happens with a paper and a computer system. So you can't necessarily trust all the information on an electronic work order. And then the Goldfish Bowl is a concept that I want to use to explain a problem that we have electronically that we don't have with a paper system. With a paper system, a work order goes to planning, and then it goes to the crafts, then it comes back to planning. You don't have supervisors just grabbing work orders before their plan and schedule because they don't even know about the work a lot of times. But with the Goldfish Bowl, that's your CMMS, with a lot of fish in here. Fish. And then some bubbles there, I guess. Everybody can see the new work orders that have been put into the system, whether they're planned or not. And there's a great temptation for craft supervisors to reach into the Goldfish Bowl and go ahead and work on something. And we never, as planners, want to tell a supervisor to wait on us, because then we'll get the reputation that we're always getting in their way and they'll shut down the planning program. Yes, they will. But from our part in planning a job, we want to avoid this situation where we're going out in the field to plan something and that looks like a brand new valve. Looks like it's already been fixed. Let's go plan this other job. Well, there's somebody working on it. Okay, well, we're wasting our time planning that job. Okay, then we go over to this pump. Okay, that pump looks pretty nasty and it's still leaking. Nobody's done anything with that pump yet. So we don't want to slow supervisors from grabbing stuff. Now, the weekly schedule, and knowing that they're accountable somewhat to follow the weekly schedule, keep supervisors somewhat at bay from just grabbing fish out of the Goldfish Bowl and working on stuff before we can plan it. But planners, if we're planning a job that it looks a little bit reactive or such a work order that we suspect the supervisor might grab it to work on it, we got to call the supervisor first. So on a reactive job, and we talked about this a few weeks ago, talking about reactive maintenance helping. Let's say there's a valve job, a pump job, and a motor job that all look reactive, brand new in the backlog. Before we start planning that job, what we would do is just check with the supervisor. Hey, this is Doc. I'm about to start planning some jobs. Did you know that there's those new hot pump job, a valve job, and a motor job? You're already doing the pump job. You already finished the valve job. Okay, that's fine. I'll just knock out a job plan for the motor job. Okay, thanks. Check with you later. Just plan the job that they don't think they're going to start today. Because of that Goldfish Bowl situation with a computer. Employee evaluations. We never want to use the computer to evaluate employees. But because then that job you've planned for 5 hours, they will put down that they worked 5 hours on it. And you're getting bad feedback. Maybe the job took 8 hours. It's okay if it took longer. Quality rules. Let's say a job took 2 days to do, but they had to do that to do the job right. Is that a bad employee? No, they did the job right. Well, why would you want to evaluate them that they took longer than the estimate? So we never want to evaluate employees based on computer information. We'll just get garbage input and be lying to ourselves. Well, how do you evaluate employees? Well, how about supervisors out in the field, which is how we've always done that. So we never want to get away from supervisors out in the field working with people. Then we don't implement the computer with a goal of eliminating all paper. There is a cost of paper, there's an environmental concern using paper, but that's not the reason we do the computer. There's a lot of things you can do electronically that you just can't do with paper. And our goal really is not elimination of paper itself, even though we hope to eliminate paper because it's easier to lose paper work orders and that stuff. And then we don't have to expect a computer to do everything. A single CMMS system, don't expect it to do everything. It's basically an equipment history database, although we're getting more and more powerful. We're linking stuff, but we had, when I worked for the electric company, a basic CMMS, but we had a different instrument calibration data system that was specifically for that. So our CMMS would spit out a work order to calibrate an instrument. The instrument tech would go to the instrument system, calibrate the instrument, report back to the CMMS that we calibrated the instrument. Then our predictive maintenance people would do Laplace transforms in their analysis in a special predictive maintenance software. And then if they wanted us to replace a bearing, they would write a work order in our CMMS to replace that bearing. Our CMMS might also spit out a work order for them to go do their route, but they would still use that separate software to do their analysis and everything. We make a lot of use of Excel, Microsoft Excel, to do scheduling, just because some of the CMMSs have made that a little bit too complicated. I suspect we'll do a better job altogether on that, so I'm looking forward to that. The overuse of templates for job plans, for, you stick this template on every work order and you call that a job plan. No, that's not a planned job. Or here's basically how you work on a pump, and you stick that on every pump job. No, that's not a plan. The planning guts that we want are, on that pump there in particular, what was important for us to remember when we worked on it from 2 years ago. That's the stuff we really want on a job plan for a pump. That we can have the generic, here's how you work on a pump, but I wouldn't call that a job plan for a pump until we're starting to customize it for that pump, and especially with the feedback over the years. User friendliness is a caution. Some of the systems are really user friendly. You feel like you're filling out a paper work order, which we're trying to get away from paper, so don't always make your computer system like paper. But it's just, some of the systems are real intuitively obvious where you are. And there's some systems, every time you click on something, a new screen pops up. You click on something there, a new screen pops up. You click on something, a new screen pops up, and pretty soon you're past Pluto, which, if you're my age, is still a planet, but you have trouble getting back to Earth. And then other systems, everything's a special code. You put in a code for that transaction, put in a code for that transaction. Just a steeper learning curve. They're all just as powerful. And some third-party vendors are creating front-end interfaces for some of those more complicated CMMSs. We'd like to get, the planner is always going to be the key user of the CMMS, so they can get used to it even if it's not super user-friendly. But we want to make it fairly friendly for engineers, craftspersons, and supervisors, and even managers to get in and out of the CMMS and stuff. All these systems are hideously expensive. I can't say that because I haven't seen all the systems, but it's a big investment. And the real money in return is understanding maintenance, is keeping things from breaking. Will this CMMS help you fulfill that mission? Be careful that you're buying the CMMS thinking that it will tell you how to do maintenance and you'll save a bunch of money, because that's just not true. You have to understand maintenance first. And then finally, creating unnecessary metrics. With a purely paper system, you're going to be seeing which is the fattest file, which is the most troublesome equipment according to your tribal knowledge and stuff. And you can have a decent plant. But now with a computer system, you can track a zillion different things. But do you need all those things to track? The first Volkswagen Beetle, it's my understanding that it had a single gauge on the dashboard. A single gauge, just one KPI. It was the speedometer. It didn't even have a fuel gauge. What happens if you run out of fuel? Well, there's this lever you tilt, and it actually gives you a puddle of gas to the sweet spot. Go find a gas station. I'm not saying we should do that, but if you're drowning in metrics, you're missing the point. We want to do planning to get better every time we work on something, improve execution. We want to do scheduling to complete more work orders. I don't know that we want to drown in measuring stuff. And now if we can automate that and have the ones flag us that we need to look at as managers, that might be great. But a lot of companies now, they use the planner to put all these metrics together for the manager, and the manager's not going to look at these. Or you might hire a separate analyst that collects all these measures, but you don't know how to look at them. So that's a wasted position. And you might lose your way into forgetting that we want super high reliability, producing our product, making a profit, or accomplishing our mission if it's not profit-based, but everything in a safe, environmental, legally correct manner. So thanks for joining me. Thanks for letting me be part of your maintenance family, and we'll talk to you next time, and God bless.